Now, I do admit the first fundamental theorem does come in handy sometimes. The first fundamental theorem says, I just for free get this. Now, if you don't see that, and I think most of us don't when we first see the first fundamental theorem of calculus, let me show you some steps. Now, forget about the differentiation process. Let's concentrate what's inside the parentheses first. Don't you agree that to integrate this, I have to find some antiderivative called big F? Evaluate the upper bound minus big F evaluate the lower bound according to the second fundamental theorem of calculus. Again, big F is some function whose derivative is a sine cubed function. But now when I come in to differentiate, I get big F prime evaluated x squared, but the chain rule says multiply by 2x. Over here, to differentiate constant gives me that. But remember, F is an antiderivative for the sine cubed function. So I'll just call it what it is. Or does that look better this way? Let's do that again. Let's make it slightly more complicated. Here too, if you so choose, we can forget about the differentiation process initially. And let's talk about what's inside the parentheses. Is some function big F whose derivative is secant function. I should say is the secant function. I'll enunciate. Evaluate the upper bound minus evaluate the lower bound. But differentiating requires twice an application of the chain rule. But again, big F as a function whose derivative is a secant function. And we are in business.